So in this session, we will discuss about the NumPy in Python. So what is NumPy? Why do we use NumPy? And what are the advantages of NumPy and disadvantages of NumPy? We will discuss in the class. So in the already we have these tuples and arrays in Python data structures. So why do we overcome that and why do we use this NumPy instead of lists and arrays? So we'll discuss all these things. So first of all, I will give some introduction to NumPy. So what is NumPy means? It's a general purpose array processing package. It is nothing but it is a package. So already you might have heard about the packages like NumPy, Pandas, Matplotlib, and Scientific Python. And if you are a beginner and you don't know about those packages, I will explain those details in the further classes. So, what is NumPy means? It's a general purpose array. It is it is like a array. It is like array only, but there are more advantages for array in NumPy. So it's a general purpose array processing package. So what do it will do means why we will use means it will provide a high performance multi-dimensional array object. So and coming to lists and arrays, the performance is very low. But because if we want to create more dimensional arrays and if we want to create more dimensions and uh, if we want to save more, if we want to store more data, it's creating a lot of confusion and it will not give a good performance. It means it will give low performance. But coming to NumPy, it will overcome the problems that are facing NumPy that are faced in lists and arrays. And this NumPy will give high performance multi-dimensional array objects and also tools for working with these arrays. And NumPy is not only a general purpose array package, but also it is like a tool for these arrays. So for manipulating arrays, for creating arrays, and also for performing high operations on these arrays, this is acting as a tool. It is also a tool for arrays. It means this NumPy is not only using package, but also we are using it as a tool for the arrays. So it is the fundamental package for scientific computing in Python. Coming to scientific computing in Python, this NumPy is a fundamental package. So in order to perform some fundamental operations, it is useful for that. So we will see those things in further classes. Now we will see. So here see what is NumPy. So NumPy is a Python library used for working with arrays. So what do you mean by NumPy means? It is a Python library. So we have many libraries. Among that library, NumPy is a library in Python. And what it will do, it will use it for working with arrays. So in order to work with arrays, we'll use NumPy. So NumPy means numerical Python. So we use this NumPy for numerical purpose only. We don't use for um, any um, characters or any other things. So we use only for numerical operations. That's why we are used for working with arrays. So there are some disadvantages in arrays. So for in order to overcome those disadvantages in arrays, we are using this NumPy for NumPy, and also we use this NumPy as a tool in order to work with arrays. Not only we are using this package, not only we are using this NumPy as package, but also we are using this NumPy as a tool in order to work with arrays. It is also same like arrays only, but the syntax is different. So we'll see all these things in the later classes. Next one. It also has functions for working in domain of linear algebra, Fourier transform, and matrices. So now, what do this NumPy contain means? It also having some various functions in order to work with linear algebra, Fourier transform, and matrices. It means if you want to work with if you want to work with matrices, or if you want to work with Fourier transforms, and if you want to work with linear algebra, there are some certain operations in which we can able to perform on these specified things. So if you want to work on these specified things, this numerical Python has some specific functions if we want to work in this domain. But coming to arrays, we don't have any functions in order to work with linear algebra and matrices. That's why linear NumPy is very uh, high in performance. It means it gives high performance rather than arrays. That's why we use NumPy for very numerical operations coming to Python. So if you want to work with more numericals in coming to linear algebra, Fourier transforms, and matrices, we'll use this NumPy. So what are the various operations that we can able to apply on this? Means we can able to see in this further lectures. Next one. NumPy was created in 2005 by Travis Oliphant. So who created this NumPy means Travis Oliphant. So he is the creator of this NumPy. And when did he create? He created this NumPy in 2005. Next one. It is an open source project and you can use it freely. So it's a open source project. It means anyone can use this project and anywhere can use this. And also you can able to use it freely. It is a complete free of cost. You don't need to spend any money over on it. So that's why it is a open source project. You can use it anywhere and you can use it. You can use openly. And also for any projects, it is very useful. So how it is useful for projects means in later lectures we'll discuss. So yes, in NumPy stands for numerical Python. So what do you mean by NumPy means it is nothing but numerical Python. For numerical purpose only we will use this NumPy. Next one. Why we use NumPy? It means what is the purpose of using this NumPy and why can't we use arrays and lists in Python? We'll see those type of things in this lecture. In Python, we have lists that serve the purpose of arrays, but they are slow to process. It means in Python we have list data structure. Why we are having this list data structure means please wait, guys. So So in Python, we will use list data structure. Already I have discussed this list in data structures. We can go through that. So we will use this list in order to show the purpose of arrays. It means if we want to perform some operations, we will use this list. What are the arrays that cannot be performed? We will perform those operations in the list. But coming to the list, if we want to process them, they are very slow. That's why it will give low performance. So that's why it gives low efficiency. So if you want to perform operations of the list, they are very slow to process. That's why we'll use this NumPy. Coming to NumPy, they are very fast. That's why we'll use NumPy over list. Next one. NumPy aims to provide an array object that is up to 50 times faster than traditional Python means. So why do we use this NumPy means it will it will provide an array object. So whatever the object that is created in array, it will provide to this. It will provide us and which is very 50 times faster than traditional Python list. So coming to Python list, this NumPy is 50 times faster, not one time or two times or three times. It is 50 times faster than Python traditional Python list. So compared to list, it is 50 times faster. It means it will perform certain operations very fastly. Within fraction of seconds, it will complete over Python list. That's why we will use this NumPy. And also that's why it is very high in performance. Next one, the array object in NumPy is called ND array. So whatever the array object in NumPy that is created, that we call it as ND array. It provides a lot of supporting functions that make working with ND array very easily. So if you want to work with ND array, we need some certain functions and certain operations. So this NumPy will provide a lot of supporting functions that we work with and arrays. Next one, arrays are very frequently used in data science where speed and resources are very important. It means in data science, coming to data science, we use this array very frequently because uh, if we want to use, if we want to perform any certain operations over an arrays or any numericals, we need speed and resources. So speed and resources are very, very important. So if the speed is very high, then it will give better performance. If the speed is less, it will give less performance. That's why we will prefer NumPy over lists and arrays. So, but we'll use this arrays concept in this NumPy also. It means um, we use this array concept with the help of this numpy, but coming to certain operations, we use this numpy. So that's why it is very, very faster than arrays. So next one. So, here we discuss why numpy is very faster than list. It means why can't we go through list? Why only we are using this numpy? And why it is very faster than list? So we'll see all these things in this session, in this slide. So NumPy arrays are stored at continuous place in memory unlike lists. It means this NumPy arrays. So whatever the NumPy arrays that we are creating, so those will be stored in continuous place in memory. It means whatever the numbers that are created in this NumPy, they all will store in continuous place. But coming to list, they will not store in continuous place. They will store at various places. So coming to this, list will take more space. So that's why it is very less in efficiency. So this NumPy arrays will take less memory compared to list. So process can access and manipulate them very efficiently. So by using this NumPy arrays, we can able to process and we can able to access, and if you want to do any changes, we can able to change. We can able to do those manipulations very efficiently. So this behavior is called locality of reference in computer science. So whatever the points that we discussed, these points are called locality of reference in computer science. So because of this reason, NumPy is very, very faster than this. And also it is optimized to work with latest CPU architectures. And also it can, and also this NumPy have very much capabilities in order to work with CPU architectures. It means if you want to work with latest CPU architectures, it is also very possible. Next one, see, NumPy is a Python library and it is written partially in Python. It is a Python library. Already we discussed. And how can we write this? It is written partially in Python. Partial, we can write this NumPy library partially in Python. But most of the parts that require fast computation are written in C or C++. So if you want to get more fast computation, most of the parts we are returning those most of the parts in C and C++, because C and C++ will give fast computation than Python. But partially we are using this NumPy and Python pandas, NumPy and NumPy operations in Python only. But most probably we have to use this in C or C++. We are, if we want to require fast computation. So that is the thing. Next one. So installation of NumPy. So if you want how to install NumPy library and how to do installation, we will discuss. So NumPy installation is very, very important. Coming to Google Colab, you no need to install any NumPy because in Google Colab already the predefined packages are already pre-installed. So you no need to install it again. So suppose if anyone is using Python or a Visual Studio Code or any Jupyter Notebook, Spider like that, we have to install this NumPy. Without installing this NumPy library, we can't use or we can't perform any certain operations of NumPy. It will give error. So here I tell how to install this NumPy. So already if you are installed the Python and pip, it means pip install Python already installed in the system. So we can able to easily install this NumPy in library very easily. So how to install it? How to install this NumPy means pip install NumPy. So this is the installation of NumPy process. So whenever you use whenever you use Jupyter Notebook or Visual Studio Code or Python like that, you have to install this package by using this command. What is this command? Pip install NumPy. So this is the introduction of the NumPy. So we will discuss what is the and we will see the all the practical things in the next class. So in the next class, I will begin with the NumPy operations and how to apply each and every operation on the numericals. We will see in the next class. So hope everyone understood this class. So thank you for watching this video. So I am winding up this session. Thank you. Bye bye.